do not have a gyro precession due to Earth rotation. Without curvature, there's no ball. Without no ball, there's no gravity. Without no gravity, there's no spin. Thank you.
You've just laid out a series of implications.
You can keep saying your script over and over again. It doesn't make it any less stupid.
Show me Earth curve, but if you can't, you have nothing. You have no argument.
Well, I have one thing. I've already demonstrated that the Earth cannot be stationary. But you want to go there and say you want to go to curvature now. Yep. We can go there too.
Hold on. You have to prove your ball first before you can prove the gyro the gyro deviations due to Earth rotation. So if you cannot prove your Earth curvature, then you have no gyro deviation based on rotation because you cannot prove Earth curve, which you need to have a ball.
Even a toddler knows that the rotation of something doesn't depend on the shape of it.
That's not an argument. You need a ball.
It's an argument against your implication that you require the ball to have rotation because he's saying that they're not related.
Yeah, you need a ball to have a rotating orb.
I mean, you can keep asserting it.
You can rotate a piece of paper too.
Yeah, that's what you're claiming. You have no curvature.
No, it's not what I'm claiming. That's reality. You can rotate a piece of paper. Don't be stupid.
I finally triggered you. Fantastic. So I know how to break your argument. Show me curvature.
You still haven't. You can rotate a piece of paper. The surface shape and the rotation of that surface are not related.
Your gyro does not work without a ball. Show me curvature, please.
Prove that.
You want to know? You want to see curvature? Lunar eclipse.
Yeah. Oh, the lunar eclipse. Show me how that proves curvature. Thank you.
Well, when the sunlight is blocked by the Earth moving in front of it, as it passes by the moon, and the Earth shadow, just like a human shadow can be cast onto the ground, the Earth shadow is cast onto the moon. Tell me, if it's not the Earth shadow, then right? What is it?
So that's an observation, right? Can you show me your science in that? What's your hypothesis?
Who said this was science? Why can't it just be an observation?
So you're inferring your nonsense on a supposition.
Spurs to agree that observations are science,
no.
By the way.
Hey, observations are not science at all. They're observations. Try again.
You're welcome to explain it, though.
Oh, looky here. Here's a picture of the Earth's shadow casting. Here's the Earth casting a shadow upward.
Oh, really? Now, okay. So that's Earth curve then.
That's the sun going below the horizon for sure.
Would you like a demonstration of how the sun sets on a flat extended plane that two equal points?
Before you go there, you're really low when you're talking. You're really low, mate.
Hello?
Oh, it's okay. I'm on a bad mic.
Well, that's Waz. What's up, Waz? How you doing, dude?
Waz is using his outside voice.
Yeah. Anyway, boys, you've been fun. Thanks for playing. I'll be back, but no hard feelings, man.
How you been, Gio?
Do yourself a favor, though. Do yourself a favor if you're going to try to come up with insults like Down syndrome and all these names. You guys better take a look in the mirror.
No, just work out that lunar eclipse for me and get back to me.
Oh man.
Using a Down syndrome guy to make fun of guys, dude. Your appeal to humiliation and your sophistry and your incredulity is
just answer the lunar eclipse question. Sometime in the future. Again, maybe put it in your book.
Can you show me? Yeah. Can you show me how it proves an Earth curve or an Earth ball in outer space?
I'm asking you. Okay, first of all, before you run away, is the lunar eclipse a real thing or not?
Is the lunar eclipse an observable phenomenon that you have no idea what causes it? Yes.
Well, we have ideas what causes it. Now, you're welcome to take any spherical object and hold it into the light and watch what happens to the shadow.
We'll call it celestial nodes that are timed, every celestial thing. So the Chinese already did it. They're called celestial nodes, and they're measurable, quantifiable, and you can predict them.
Two questions then for that. Why can't I see it from the southern hemisphere? And two, what keeps the moon in the sky at all?
Yeah, exactly, right. So what keeps the moon in the sky, you'll never know. You'll always ever speculate. You'll never know the answer or truth to it. You'll just have a religion and a supposition to give you peace of mind. In reality, you won't know jack squat.
Again,
if you choose to ignore parts of science just to make an argument, then that's what you're going to get.
As opposed to, the ability to be open to possible...
And the second question, why can't I see the northern hemisphere?
There's a difference between saying we don't know versus what you're doing, which is gatekeeping us ever knowing by saying that we'll only ever suppose. Like, you're explicitly preventing any existing theory from being considered and basically pulling your ears saying that it's impossible.
Theory. Is it a hypothesis or is it a theory? Because if we have a hypothesis, then we can actually use science. But if we have a theory, then we're going to just base it on consensus. And that means it's groupthink. So bullshit.
Well, the hypothesis is simple. I believe that the Earth crossing in front of the sun creates the lunar eclipse shadow on the moon.
So from the ashes, I wanted to respond to that in
groupthink.
in terms of that.
That's all you got.
Well, Data, chill for a second, bro. Let someone else speak. You're just becoming a motor mouth, and it's just totally hogging the conversation. So I'm not saying I have to speak, but at least like let others come in, because otherwise you're just going nonstop.
Well, then he's just going to leave because he only is here so he can talk.
Oh, okay. So there's,
I'm just here. I'm just actually here to play, learn your guys' argument, and then just beat you with them. That's all.
Yeah, you lost.
Well, I think it's
he's got no curvature, but thinks he lives on a ball. All right, but
I wanted to respond to what From the Ashes was saying about the blackness of the moon during the eclipse. There's a couple things about it that to me indicate that it's not the Earth that's causing that. One of them is the fact that during lunar eclipses, that what could be called a shadow or whatever that thing is, comes from all different angles at different times at different eclipses. And not only that, but sometimes it comes in, like, let's say it comes in from the upper left and it covers the moon, and then it kind of phases over to the right, and then it goes up out of the upper right. Sometimes it comes from the top and goes out the bottom. Sometimes it comes from the bottom and actually comes back out the bottom, or it comes from the top and comes back out the top. Like, it makes a 180-degree change in direction. So that's very interesting. It looks more like a lens of some sort that seems to be shifting over the moon, much more than three physical balls lining up. So there's that point. And then the second point is that the curve of that shadow should be 4 times less sharp than the moon, because the Earth's supposed to be 4 times larger, but the shadow is actually often the same size as the moon, and or it changes as well. So there's those things, that the phasing of the way the shadow comes across, and then the actual curvature of it, that don't seem to me to align with 3 balls lining up, but seem to look more like a lensing effect, which is what all the ancients said that these were. Like Data said, they're the nodes of the moon. They're celestial, they're the moon's nodes essentially. And when those line up with the sun and the moon, we get these eclipses. So it makes sense that at those nodes, in my mind, there might be some kind of electromagnetic field. There could be an actual black body or a lens of some sort that essentially polarizes and absorbs the light at the time of the lunar eclipse. That's my view on it.
So were you actually interested in the actual heliocentric model explanation for that?
I'm open to hearing anyone's viewpoint. Yeah, go ahead.
Yeah,
okay,
I just want to. For the
first point,
the moon. Like I didn't have it. Sorry, can I just answer something that I didn't look like I ran away from the question, because I don't like that. I'm able to answer this. But first of all, you got to understand the moon. I'm just gonna say this: the moon is not a perfect orbit around, and due to the fact that we have moonrise and moonsets in the different hemispheres, these are things to take into account at the angle at which the sunlight would hit. And that's all I'm going to say. And I don't want to take over the conversation either. So have at it.
Well, yeah, the moon is on a 5-degree tilt in orbit. The moon is on a 5-degree tilt in orbit around the Earth. So when a lunar eclipse happens, it can hit the moon from either side of the orbital plane.
Yeah, but that's not what it's doing when you line up the nodes, because the nodes in the heliocentric model are essentially the meeting point of the ecliptic and the orbit of the moon. So like over a flat Earth, it would just be the change in the tilt of the sun and the moon, which is why like when we see the moon, sometimes it looks like the light is angled downwards towards the sun. Other times it's angled upwards. So if they're just on a slightly tilt, you're going to get that 5-degree tilt. But on the heliocentric model, it's just the ecliptic with the rotation of the moon, or the orbit of the moon. And so when those intersect, you get the eclipse. But if you actually look at the 3 balls lining up, the moon or the shadow would never come from the top and make a 180-degree change. That's impossible, and it could never come in from those other angles. So to me, it rules out the idea that it's 3 balls lining up. For me, 100%. If others believe it, I respect your belief.
The appearance of the shadow and which way it goes is dependent upon the observer's latitude.
Because you're on a sphere.
Yeah, that might change the angle of it, but it's not going to change the actual rotational direction. Like it will
definitely change the direction of the shadow traveling. Your latitude will change which direction that shadow will move across the moon.
Yeah, remember that I see from here in New Zealand in the South Island, I see the same phase of the moon you do each night, but mine is flipped upside down.
Yeah, that's how I see it on a geocentric stationary Earth. Yeah, that's exactly how the celestial objects present themselves. They're like objects in the ceiling, essentially, and you can just see them from different angles.
And when I face south, my stars rotate clockwise.
Whoops.
That doesn't mean you live on a ball, though. At all.
It's pretty hard to explain. It's pretty hard to explain two oppositely rotating celestial poles on a flat
They're
Earth.
not. They're one
I could
direction,
respond
east
to
west.
the southern stars, but I want to hear Data. What are your thoughts on it?
So when I look at any aviation that I've been involved with, there's no adjustment for physical Earth curve. Everything we see is equal points of horizontal, creating a horizontal plane, a horizontal line, which is possible on an extended plane. The heavenly bodies do not dictate the surface below my feet. What I have seen is the apparent apparent rotation based on refraction. That's what I've seen.
Interesting. So in terms of refraction, like in what way, like in terms of like, this is a really interesting idea. This guy, I don't know if you guys know Matrix. He mentioned this the other day. You know how you can take a glass of water and you can put an arrow behind it and you pour water in the glass and the arrow changes direction? Now, I'm not saying this is what the southern stars are, but he made this just interesting idea of if there is a liquid, like let's say there is a dome or liquid of some sort, in the same way that the water changes the angle of the direction of the arrow. What if that's what's happening? What if, I'm not saying it is, it's just an interesting idea. What if you look south like that you're actually just getting that opposite rotation in the same way when you pour water in the glass, it changes direction.
Here's what's
no amount of refraction will make a single distinct point be directly south for all observers south of the equator.
Here's an interesting point.
It's just the perspective limits, but
it's
yeah,
a rotation center point. It's a distinct point south, directly south for all observers south of the equator.
It's not directly south, and it's not a south pole according to astronomy. So stop with that lie.
It is directly south.
Again, it's not. And that's why
it is. It's not the magnetic.
There's three different south poles, right? What I noticed about
there's not even three.
What I noticed about this observation is that even over in Antarctica itself, being the square mile, 5 million square miles. Am I got that correct? Of a plateau. That plateau has no dip, no drop, no curvature, nothing. And what you're trying to do is conflate the rotation, which is east to west still, as opposite direction as you're living upside down in a ball. So for me to accept...
Is it just me, or are you breaking up? Is he breaking up?
No, it sounds fine to me.
So for me to accept the rotation in the opposite direction, which is still rising east to west, is telling me that I live upside down in a ball, I'd have to disagree. I would have to refer to my observable reality, which is water, extended plane, horizon, convergence due to the angular resolution, and the sunset due to refraction. Everything, what I see in my reality above in the heavens, appears to be because of refraction. I only see it as an 18-mile circumference and a 3-mile radius. So all those stars and everything are much closer than millions and millions of miles away. And everything that I see disappears due to my angular limit and refraction. So I cannot reconcile, personally, the difference between why it's rotating in an opposite direction when I know it's going east to west, but I cannot reconcile living upside down in a ball. Sorry, I don't see it. There's no...
What's fun is you can actually take some single recording device that has two cameras, like say your cell phone, have one pointing up and the other one pointing down.
Yeah,
and when you rotate that phone in a single direction, you see up above your head something rotating counterclockwise and something down below rotating clockwise. It's the exact same way that the heliocentric model shows that it has to work.
I've animated it, and you can get opposite rotation through refraction, taking if you have concentric circles as an example. I'm sure you've seen demonstrations that you can take refraction, you can split the concentric circles as if creating two polar opposites.
It doesn't work though. Remember,
hold on. Let me finish. Let me finish. No, it does.
Is this the one with the inverted glass dome?
So listen, I've done it in
You can do it like that with a dome, yeah.
So let me finish.
Inverted upside down. That's the fun part.
Let me finish. I've done it in Blender. What I can't get to work is the opposite rotation in that program without separating the concentric circles. That's the error. So you do have to have that position. But again, I cannot reconcile living upside down on a ball when my observable reality tells me it's a flat extended plane, and that I know most of my vision is based on perspective, which is the angle of light to my eye, and the area above me is all refracted. The whole upper atmosphere is like a crystal dome. How I'm conflating it is my observational reality subjected to my field of view, which is my own personal dome. So if you want to say that it's
absolutely.
So
no flat surface has a horizon that distant objects are obstructed behind.
I gotta jump in. I hear you. I gotta jump in because I just put an image that posted like right when Data said that. It was perfect Data. That was awesome. And I just posted an image. That's actually just Walter Bislin's little model, which I like it as just a basic little model. And so that shows how you could have, let's say, a dome of stars, or those stars could be flat. And just like Data just said, when you have your own personal dome or your personal point of view, like he said, that's a good example. Field of view. Yeah, that's the best way to describe it. Field of view. So if
you should read the rest of the page that comes from.
That field, I'm very aware of Walter Bislin's entire, yeah, for sure. I know exactly who he is and everything. But anyway, so
yeah, the refraction that he had to use is inconsistent with reality.
What I'm saying just simply is that if you take that, the one I just posted a still image, but if you do an animation of it, as your field of view rotates, because that's what's happening, you only have a limited field of view. So as the sky moves over you, those objects in the sky are all going to be essentially, you could call it refracting, you could call it projecting into your field of view. And the way that that happens, that southern star rotation, if you spin that sphere, that's exactly what you get. And all it is the flat stars above your field of view. So just by a perspective, you would get that southern star movement as shown exactly in that little small scale model.
That's
if you read the rest of it, it does go through to explain that the amount of refraction required is inconsistent with reality.
Don't care. That's how I would see my reality, is through that perception.
Don't care.
Not observe.
Okay, I mean, you could just ignore basically all of optical science. Everything in optics says that you're wrong.
I'm personally not requesting that you think this way. I'm just saying this is what I think is going on, and it correlates. The southern star rotation is exactly can be seen in this very simple model, which is just a flat plane Earth, stars above, field of view.
It doesn't
just ignore the fact that the modeler, the person who created it in the first place, says that the refraction required is inconsistent with reality. Just ignore that part.
What proof is that? Inconsistent with what reality? Something. I mean, I've looked into what he's done. He doesn't have some full understanding of refraction, so he's just using that to obfuscate the fact that this can be modeled very simply, which everyone can see. He's just saying, oh, but it doesn't fit the radius of with refraction equations, which really have nothing to do. This right here shows how every star over your, because you only have a limited field of view. So, and the thing is as the stars go out in the outer rim, they're spaced out further. And because they're spaced out further, that's going to project into your personal field of view differently than they will in the north where they're tighter together. That's another big factor. But if you spin that little personal, field of view sphere, the stars are going to move clockwise and anti-clockwise. So you're in a sphere. We're not on the outside of a sphere, in my viewpoint. We're not on a globular Earth. We're on the inside of concentric spheres, essentially. The entire Earth is maybe the largest, and then our own brain, our own body, and then our own field of view are just concentric spheres, essentially, and they're all spinning. But we're stationary on the Earth.
If you observe that model a little bit closer, you'll notice that if you gain altitude, it stops working.
Stars actually start to fade away at high altitude, so that's bringing in a whole nother factor.
Wow, citation definitely needed.
Doofus, I have a question for you. What causes the apparent?
They don't fade away with altitude.
What causes the apparent junction of the sky and ground, Doofus?
The horizon is the last part of the surface of the Earth that you can see. We've already been through this.
What causes it?
It's just the last part of the surface you can see.
What causes the last part of the Earth you can see? What is that limit?
I mean,
optical extinction.
What the hell? I mean, you can't see the surface behind it. It's just the last part that you can see.
Yeah, what causes that last part to, what causes the cutoff, the junction?
Oh my God. Come on, man. You know I already work with the globe.
What causes the apparent junction of the sky and ground, bro?
The horizon is the last bit of the surface you can see because the Earth is spherical.
So the apparent junction, is that a physical location or is that an apparent location?
It's an apparent location.
So what causes the
If I was a
convergence?
globe earther, I would say it's both.
Wait, how's it?
What causes
How's it
it?
not both?
If I was
What
a globe
causes-
earther, I would say it's both. Yeah.
What causes?
Yeah,
What causes?
How's it not both?
If you want to prove your model a little,
I've explained this before. How it's both. Simply, it's just like when you put the pencil in the
makes the
water,
exact
and you see
position of it
and you see the
apparent.
apparent position of the
Everyone knows
pencil.
what's up.
Excuse me, buddy.
Yeah,
Excuse me,
let's
buddy.
get rid
It's
of
like
the
it's not like I'm not talking, you know. So it's just the same as if if of course it would be both because it's the same principle as if you put the pencil in the water and you can see the apparent position of the pencil. Why would you see the apparent position of the pencil had the pencil not been there?
Yeah,
Right.
So it's
And then
refraction. that causes it then.
the location of the ground is still physical. However, the horizon's location is apparent.
So the apparent junction, them touching, is not actually happening, right?
It's the last part of the surface you see,
Right.
and then you see sky above that.
So the last part of the surface you can see. So the rising of the ground is caused by what?
The shape of it. What do you mean?
The shape of
There's
it.
no
writing it
rising.
down.
There's no rising of the
shape
ground.
of it. Awesome. That's exactly right.
It's not a
Welcome to Flat Earth.
rising of the ground.
There's no rising. That's right. So as you
Not on a
look
tangent sphere. There's no rising on the ground. It's
on
all
a tangent sphere, so I
it's
can use
all
a right
level.
angle triangle.
If
to
you draw a
navigate.
chord from there to the horizon, yeah, I mean, basically,
Yeah.
if you're just doing it on a tangent, yeah, it's all falling
Yeah.
away from you. At
How
the
are you
same
doing a
time.
chord? How are you doing a chord? You need a radius first, right? So look,
Negative.
what causes
Chord,
yeah,
it does not require a radius.
What causes?
He does this every
Listen,
time he
when
walks
two
in the
objects-
room, and he
Yeah.
says
He
the
just wants
same
to lie
spiel
about what
over
I'm
and over and
saying.
over
That's
again.
all.
Lie about what I'm saying. No, I'm trying
It's
to get some
fucking annoying,
clarification.
man.
This is what you've told me so far.
A chord
I've
does
already-
not require
People
a
who've seen you
radius.
do this already are like
Yeah. So let me
disenfranchised.
finish. Yeah, man, chill out. Last time you talked to me, you said, "Come on, man, the horizon." I told you before. The last time, it's the last limit you can see. And what is it again? The shape. You said because we live on a sphere, right?
Yeah.
Okay, because we live on a sphere.
You want to know
So
how
you-
I know that, right?
Because we live on a sphere. Because you think you can live upside down on a ball and not detect it.
No, no. Do you
down.
really actually want to know how I know that?
Upside down.
Because you live on a ball in your mind.
A ball.
What direction does light bend through a density gradient where the highest density is below?
Bends downward.
Right. And what does the apparent position of something in the
always.
distance appear to be displaced? What direction is it displaced?
Depends
I would
on
say not always.
It depends on
always
the
bend.
matter. It depends on the
Depends
matter.
Like he
Look at
said,
the
it
hand.
bends towards the
Correct answer.
denser medium. It
Upward.
bends towards the denser medium. He's correct.
Yeah, exactly. Which is downward usually.
Yep. Yep. The
Right,
light
so-
bends down. Distant objects
know,
will
is it?
appear to be displaced upward.
Yeah. As light moves away from you and it hits a different medium, it will bend downward. So
Remember
Not
when
a
what's his
different
name
medium.
said
We're
that
all
Jeremy
talking
had
about
Down,
just atmosphere here.
Down
yeah, and
syndrome?
light will bend down away from you. So if you want to look at the apparent junction of the sky and ground, which is
So you
a
haven't actually
convergence
let me
point.
finish my explanation yet.
Okay, well,
Well,
you never gave me an answer
downity.
entirely. You
Downity.
just told me that. Come on, man. I told you before. It's the last limit you can see, and then you went to it's the
Come
shape
on,
of the
man.
Earth. Now we were talking about refraction. So again, I'm just going to clarify my question because I don't think you've answered it yet. There's an apparent rising of the ground, which isn't actually happening, and there's a convergence point there. So is that Earth curve causing
you can
that?
hear
or is
the
it our eyesight?
endorphin release when
is
he
that-
talks at you like
Is
this.
that the
It's
Earth
weird.
curvature? It's the Earth curvature causing that, or is it our eyesight causing that? The apparent junction of the sky and ground.
So now I'm going to continue on what I was going to say earlier, which is
Can I write that down as
as-
your response then?
so that the light bending downward causes distant objects to be displaced upward. On a flat Earth, it should start to look concave.
Do you have a flat Earth model and a globe model to compare the two?
I have an atmosphere in reality.
All right.
Well,
So
what I-
now
what I
we'll go
experience-
back. You can't have a independent variable here in your hypothesis. You just have a supposition. So listen,
I don't
you
just
tell
have a
me-
supposition. I have
Can
a
you tell me-
barometer. I have a barometer and I have
Containment.
altitude
Containment,
measurements.
okay. Yeah, containment and measurement.
So we know
gas
that
pressure.
we know that the atmosphere is more dense closer to the ground. So we know
So
that
guess what?
refraction
So guess what?
refraction in the general
What
case in our
causes the
atmosphere is going to bend light.
convergence?
Refraction in the general case in our atmosphere will bend light downward, and distant objects will appear to rise.
Okay.
If the Earth were actually flat,
Mhm.
it would appear to be concave. It doesn't look
Okay.
like that.
And we know
So the
this from
convergence.
laboratory
The
experiments.
convergence is what? What is
Can
the
we
convergence to you?
Data, can you take us a break? Can we let Grim
Hold on.
speak?
I want an answer from this guy so I can write it down. He still hasn't answered what
We
causes the
don't care what you're
convergence.
writing
Oh,
down
no, I
or
definitely
not writing
did.
down.
What did you say again?
I just wanted to hear what Grim was. I mean, it's kind
Yeah,
of
I'll
fair to
end
let other
as soon as I
people
get an
speak
answer
as well.
from him. I'll end and
All right.
I'll be gone. So what causes
No,
the junction?
no,
What's
all
the
I-
apparent
that's all I was
convergence?
saying.
What's the cause of it?
It's the
The
last part
actual
of the
convergence.
surface you can see.
Right.
The
What
cause
causes
of
that
the
though?
cause of the apparent
Why do I
convergence
have
is
a
the
limit?
actual convergence.
Why do I have a limit to that point? What
That's
causes
it.
that limit?
Geometry and physics.
Geometry
You can't
and
see
physics.
past
Right. I'm writing it
geometry,
down.
and refraction
Can't-
can only get
so-
you to see so far, so much
So
further.
geometry and physics, so not Earth curve then.
Think of
Geometry
it
is
like
part
a
of Earth
zone.
curve. Goodness gracious.
He
Oh,
always says
I'm
that.
sorry, the
He
geometry of
wants
the
to
Earth
split up
curve,
your answer
or
as if it's a new answer.
Is it your eyesight?
It's not tied to the old answer. It's a new,
Grim,
different,
your
separate
endorphins
answer.
are going off the roof.
No,
Listen
I
to
was
you, bud.
laughing my
You're
ass
really
off when you tried to do that shit to
You're
me.
really
You took
excited.
every
You're really
single one of
excited.
the things I said
Yeah.
and separated them all as if they were to cancel and supersede the last
You
thing
said
I
last. You
said.
told me. You said,
But
"Come
they
on, man,
were
the
all
horizon." I told you
all
before.
together.
It's the
Those things
last
were
limit you see.
all
Geometry
in
and physics
context all
causes it.
together, just like what
He
he's
talks
saying.
about geometry. There's no hump of Earth curvature in the way. It's just the
Yeah, but
ceiling and the floor
Lemon, you don't
ramping
have
you
to help
higher.
this. Yeah,
I don't have
yeah,
to help him.
exactly.
It's just
See,
optics.
That's what I'm saying this whole time, and I'm getting the point is why I'm documenting.
No, I'm
because it's a
saying
really
Lemon
easy
doesn't have to
question.
help the actual Glober because he was just trying to explain to you simply what the man was trying to say.
See, it's
he wasn't really helping you.
Do you understand, Grim, that it's a very easy
Do I
question to
understand?
answer?
I
Yeah,
overstand.
do you understand? So why did you obfuscate when I asked you? Do you want me to read your response?
What's
It's a
obfuscate?
really
Why would I obfuscate? The only
Okay.
point of this entire
Grim,
thing
here's
is
what
to have you
I
just be
wrote.
quiet
Here's
for
what
a
I wrote
minute
for you,
and
buddy.
quit feeling yourself so hard.
Yeah, here's
Let
what I
other
wrote
people
for
have
you.
a conversation because nobody really gives a fuck what you wrote for me.
Yeah.
I don't care
Well,
what
you
you wrote for
should
me.
because
He doesn't
it's
care
pretty
what you wrote
entertaining.
for him.
It's
It's
entertaining.
not
Grim.
entertaining. It's annoying.
It's
It's just
entertaining
like
as fuck.
white noise. It sounds like
Do you want
white
me to read
noise
your
to me.
response?
It's
You should write
boring
down
as hell.
You should write down the
You're
definition of
you're
geometry
a
while you're at it.
nuisance.
What's the
I
definition
would
of
say,
geometry?
I would say both you guys.
You're in a room where literally nobody wants to hear your shit. Not even your fellow comrades.
Can't answer
They're
my
over
can't
you.
even answer my questions.
Means that there's a hump of Earth curvature in the way. There's nothing in the way. It's just optics and the diffraction limit. It's like a zone
Okay, he
of
was actually
light.
asking me instead of you, though.
Yeah, but you guys take a minute to just bicker and not even get to the freaking point. Just get to the
I
point.
asked them how many times though.
Well, I definitely got to the point.
How many
What
times do
I
I
was
have to
gonna
ask
say
them?
is that
Do you
because we're
understand? There's no reason for you guys to answer the way you're answering when I ask you what causes the apparent junction of the sky and ground. There's no reason to do what you're doing, but you're doing it, and then you're trying to fucking deflect from it. It's just priceless shit, man.
What you're doing is you're trying to look for a specific. What you're doing, data. What you're doing is you're looking for data. Hey, flat Earth data. Data. You're looking for a specific answer, the one that you want. It doesn't matter what anybody else says to you. You don't get that answer. You think it's you don't get that answer. You think it's hilarious, but it doesn't matter because reality disagrees with you.
Yeah, I'm not interested in that. I'm interested in your response. You see, I'm writing down reality based on your response. That's the problem you're not understanding. So what is it? What causes the junction? What's the convergence?
Well, data. It sounds
The answer that you want, the answer that you are desperately trying to get me to say is something related to perspective and convergence. However, that is not the answer I'm giving you. And so now you think I'm not answering your question.
Everybody's talking at the same time, and no one's really able to finish a thought. But I think in order to let each other finish, let's all try to be succinct. Like try to say something and then quit, and then let someone else fully respond. Let them.
Why so difficult question?
Is monologue. So let's try to keep something good.
Why so difficult? Why so difficult, huh, guys? Why can't you just tell me it's the eyesight perspective? You don't. You tell me this.
Because that's not the right answer.
Oh, okay. So the apparent junction is not caused by eyesight.
That's correct. It is not caused by eyesight.
You can have a different cosmology. There's nothing.
Parent junction.
You guys can have different cosmologies. There would be no need for one to force one on the other. So you guys can both have your viewpoints. You know, like.
Why is it so difficult to answer the question? That's what I'm talking about.
That's
why
I did answer the question. You just didn't like the answer.
This is what you wrote last, or you said, "Come on, man, the horizon." I told you before, it's the last limit you can see. I was like, okay, what causes that last limit?
It's not last limit. It's the last part of the surface you can see.
Oh, sorry, I said limit. The last part of the
So
surface
then
you
you
can see,
think that
right?
the horizon is the physical ball of the Earth? Like if you think Earth is a sphere, you're saying that the horizon to you is actually where that ball meets the sky?
No. Every
Thank you.
part of the ball would be meeting the sky. What do you mean?
We're just trying to get. I'm trying to get to something succinct. Like, Data's saying that that you have like essentially an optical extinction, and Lemon was saying that as well, and so on, and the perspective and how that works. And then you're saying the Earth is a globe and everything. So then I'm just asking, like, what are you saying the horizon is? Are you saying that that's the actual physical curve of the ball that you're on?
Yes, mediated by refraction. You can see as far on the surface as you can, and then you can't see the surface anymore.
So, bro, you
because
think
the Earth is in the way.
Hold on. So you and me go for a jog, 30 minutes. We're going over the edge of the ball Earth.
Say that again.
You and me will take about 20, 30 minutes to jog 3 miles. Are we going to be going over the edge of the Earth 3 miles from the observers watching us run?
Every observer is at the top of the sphere.
So that's a yes then?
Every observer, including you and me, running is always at the top of the sphere.
So that's a yes then? You can run over the edge of the Earth.
Stupid. Okay.
You can run over the edge 30 miles away.
That's pretty obvious.
I mean, depends on what you mean by edge. What are you implying when you say there's an edge? All he said was that there's some limit at which you can't see the surface. Is that what you're considering the edge?
What was the previous response? Because I didn't say an edge. Your buddy did, right?
Nope, I didn't say anything about an edge either.
You were the one who initiated calling it the edge.
No, I didn't. You agreed to it, right? The other guy who answered, you agreed to it. That's where
what you meant is that part of the globe. That curve.
I never said anything about an edge at all, ever.
If you jog 3 miles, you're going over a curve, is what they're claiming.
Yeah, that's what you're saying to me, dude.
I didn't say anything about an edge.
You're saying to me that you can go for a 30-minute jog and start going down over the ball from the observer on top of the hill. That's what you're saying, or top of the sphere.
Yeah, the entire time that you are jogging from point A to point B, during the jog, you are on top of the sphere.
Are you focused? The guy watching you run away from him, you're telling me at 30 minutes or 20 minutes he's going to be going down over the sphere edge. That's what you're telling me.
What are
you from the main observer watching the runner go away, it only takes him about 20, 30 minutes to start going down over the edge. That's what you're saying, right?
I didn't say the word edge. You keep inserting the word edge.
Hold on. So you guys claim that you can measure dip drop for a 6-foot observer, right? So at some point at, let's say, 4 miles, there's going to be a certain drop. You're saying that the runner takes 20, 30 minutes to run down that distance, correct?
No, that's what you're saying.
Oh, well, I'm just clarifying your model.
Well, I mean, to be fair, you
seem to be rewording exactly what he's saying. Why not just go with what he's saying?
Yeah, you are kind of assuming his model, I guess, just based on a general like heliocentric globe Earth model. But
wait, can't they measure dip or drop? Can't they measure dip or drop for a 6-foot observer? So you're telling me the runner running away, they can't measure his drop?
You can
all of a sudden now?
I don't think that I think the Earth is a level plane, so I don't think that can be measured. But I'm sure they will say that photos that are cutting things off at different distances from the bottom up, they'll claim that that is Earth curve. However, what's interesting about that, and the thing that to me proves that it's actually just the changing in the atmosphere, is because if you go to the same location, the same distance, exact same spot on different days, different times of the year, just different atmospheric conditions, you're going to get different amounts of those buildings cut off. So some days it's going to be only cut off a little bit. Some days will be cut off more. Some days will be cut off less. So that shows that actually it is just a magnification of the atmosphere that's magnifying that, and not an actual consistent curve of a globe Earth.
Is a problem?
Hold on. You can see distant objects being displaced vertically. Yeah, you just used refraction just now, just so you know.
Yeah, we
just use the globe mathematics to try to say the globe isn't real. So
no,
the thing that we can see can actually
check this out.
Not you. You stop talking. What Gio said, I think it was Gio, the idea that it will change on a different day, yes. And knowing the distance to the objects and the height of the objects in the distance, we can calculate what we expect to see using the refraction index. Just like the picture I posted earlier of the mountain that shoots from one island in New Zealand across the strait into the other island, and the 2,885 meter mountain has 2,000 meters missing, and you're telling me that's convergence from a 3-meter observer. I'm sorry. It doesn't cut. Because you're missing half of the top of the southern island.
Except because the angular size of 2,000 meters is not 0.02. So no, it's not the
That's
diffraction
because
limit.
of the diffraction limit.
Diffraction limit won't help in this particular case because the distant object still has resolvable details on it. If those resolvable details are suddenly not resolvable and half the object is missing, that's not diffraction.
Are you using a camera or using your eyesight?
So you're saying with a better optical device you can reveal more of something?
Using diffraction.
The diffraction limit, obviously, yes.
Okay, let me just spoil it for you. There's an entire mountain range before that mountain.
Past the resolution power of the camera.
No.
Except that doesn't happen in reality now, does it?
In the photo from 1 minute after the last hour, you can clearly see there is resolvable detail in the mountain, so it is not being diffraction limited. This image is resolvable by the optic.
It's reached the diffraction limit up and down from the eye level of the optic. Up and down from the eye level of the optic. That's where the
property of the angle incoming.
And there's a mountain. There's a shot from inside the mountain range itself. You can see those visible features there.
Well, we can look at that one if you post it. I just want to say, everyone's been interrupting Lemon. Like Lemon hasn't even been able to get through a whole thing. I just want to say it's not cool. So let's try to give each other the floor because I just feel like Lemon's been talked over every time he talks. I wanted to hear what he's saying.
Thank you.
Fair enough.
After 4 years of dealing with these globers, I just gish gallop right over them. The thing is, you need to apply the diffraction limit up and down from the eye level of the optic to see if the angle is wide enough and big enough to be resolved into a 2D image. Otherwise, you have an unresolvable horizon line. You have to start it from the eye level of the optic up and down to get it to disappear over quote-unquote the curvature of the Earth.
So that should change with aperture size, except it doesn't.
The aperture size would be irrelevant anyway. You just have a wider lens that would be way higher than the level of the eyes that are actually observing the image anyway.
But if you got a wider aperture, then you should be able to resolve more of that mountain. But that's not what happens.
Well, these are different things.
Also, things like diffraction. Sorry, go ahead.
What Lemon was describing is the actual human eye and how the actual eye functions. You might be talking about a photograph, which involves aperture and a bunch of other things. If you're using a camera, you're bringing in a whole different device, involved in any of these observations. But I think what Lemon was describing was the direct observation, and what he's saying is the case. I mean, even with the naked eye, when we can see long distances, that is how it functions.
Both eyes and cameras and telescopes, all of those have lenses and apertures. They all work the same way with light.
With Lemon's idea, you should be able to zoom in on the horizon and make it go further. But we can't.
The diffraction limit of an optic is dependent on its aperture and the wavelength of light incoming. It does not depend on which angle the light enters the aperture. So no, it's not like you choose where vertically in the image you are, and depending on that, you either are or are not seeing something. That's not how diffraction works.
Well, the way we're getting into some different things.
So is it not? I'm sorry, dude. Go ahead.
Obvious. Well, I was just going to say, go ahead, Graham. But I was just going to say, to me, it's just obvious that there's an optical extinction perspective. That's pretty much it. And everything is upon a planar Earth. There's a little bit of refraction that can happen with like stooping and looming and I always want to say phantasmagoria, but that was that video game from the 90s.
I remember that.
Remember that game? But Phantom Morgana. But so we get some of those effects. But to me, at least, the Earth is measurably and observably, to me, to be level in all ways. There's a little bit of refraction that can happen, but yeah, and then it's just the optical extinction and the perspective points, like in that way.
Perspective over a flat surface can never make something that's above your altitude appear below your eye level.
Second, my man. We were just giving each other the floor there, so obviously I was going to say something. So I don't mean to be rude, but I don't see Flat Earth Data actually acknowledging that point, though, that because he's like, this apparent horizon position and all of that. But when I'm saying that also with the refraction in the pencil in the water, that you wouldn't see the pencil refracted from its original location had the pencil not existed in the first place. So that's at least something you need to address, my man, and quit hand waving and pretending like it's not an actual valid argument against your case, because it definitely is. And it's something that you need to address so that we know that you're serious about this fucking conversation.
Well, there's a lot of visual effects here that we need to take into account. Something higher can appear lower than something else due to perspective, and you can look through a bottle with a small lipped opening that's way smaller than the bigger round base. And if you look through that small opening toward the bottom of the bottle, it will appear as if the smaller opening is bigger than the bigger base, based off of it being at a certain distance with the focal point. So that can happen with these mountains and these other things going below things that are shorter in the foreground as well. So it would look like something taller is shorter than something that's,
I really don't have any idea what you're trying to say to me, man. I'm sorry. I'm trying to get
because somebody was saying that perspective would never make something higher go below eye level. Well, it looks like something bigger at the base of the bottle is going below something that's shorter in the foreground of the bottle if you look through the lip of the bottle even. So
I swear to God, after listening to you for like a half a minute, I don't even remember what the fuck I was saying.
You're too drugged out to follow the conversation. For the people that aren't,
you're not actually you're not addressing my fucking point. You're literally not
you are so boring.
It is what it is. But the thing is, something bigger in the background is going below something shorter in the foreground right there. So with the refractive effects, looking over mountains and looking over great distances in the distance, along with perspective, along with everything else, something higher in the background can go below something shorter in the foreground.
How does that address my point, Lemon? I don't mean to be rude.
There was another point that was on the table before you entered in the conversation with that point.
All right, cool. So when I took the floor for a second and took my turn and waited and then addressed Flat Earth data, particularly about this point not being acknowledged, and you immediately, after the very last breath I took in my word, joined right in with this non sequitur issue, another just not acknowledging my fucking point moment.
I think he was there was kind of two conversations going on because I think he was responding to what Doofus had said. However, and your mic is a little low, Grim. Like I guess I did hear that you said Flat Earth Data, but I don't even know if Flat Earth Data heard you, or I don't know if he's here because I think he's muted. But I do hear what you were saying. Like I just don't know if Data's here right now. But I think Lemon was responding to what Doofus was saying about.
I actually didn't hear what he said, but I'm just gonna try to find his comment. I'll be right back.
Well, I think Grim, if you're here, Grim was asking you something directly. So maybe Grim, if you want to just repeat it, I think he's here now.
All right, cool. So I just wanted you to acknowledge at least the conversation about when you're asking about your apparent horizon and which one is which, the geometric or the apparent. And I'm saying that one is both. The geometric must be there, for the apparent horizon to be there. And the example I give, which is a pretty valid example, is the pencil in the water. As you can see the apparent location of the pencil and the original location of the pencil by following you put it there. So that you
can I ask you a question, Grim? I got your point.
Would you see? I know, but let me just say it. So you have to at least address that answer. That there is an actual.
So land is there. The land is there.
Horizon.
Listen, yeah, the land is there. And let me ask you a question, Grim. Can I have equal points of elevation on an extended plane creating a horizon?
See what I mean right there? Like you literally, can you have equal points on a sphere? Yes.
Can I have? Let me finish, please. Let me finish. Can I have equal points of elevation on a plane and create a horizon?
On a plane.
Can I have equal points of elevation to create a horizontal path on a plane?
I don't know about, can you do it in infrared? Can you do it in infrared?
Wavelengths of light have different diffraction limits.
Are you talking about in a vacuum or in actual atmosphere?
I'm talking about reality, but.
Well, how do we know that we're on a plane in reality, dude?
So again,
talking about reality.
Can you have? Listen to the question, Grim. Can I create equal points of elevation on a plane, creating a horizon?
Yeah, but you just literally asked you to clarify: are we in a vacuum or not? And you said we're in reality, and I said, well, you're already asserting that we're on a plane in reality.
Yep. So listen, in reality,
So
can that
how
be
do we
a
know
plausible?
that's reality?
In reality, could that be a plausible scenario?
Is there a vacuum in reality?
If we are on a plane.
This is my point, dude.
Yeah, if we're on a
Okay,
plane.
listen to me very carefully. Listen to me very carefully. I'm asking you to clarify. Listen to me very carefully, right?
Yeah.
So when I ask you to clarify, are we in a vacuum? You say, no, we're in reality. Don't they have little vacuums in reality?
No, they're man-made constructions. They're not natural phenomena. The natural phenomenon we observe.
Yeah, but it's in reality, dude.
The natural phenomenon that we
observe. The computer that you're looking at is in reality.
Let me know when you're done.
Yeah, I'll let you know when I'm done. The big indicator will be when my last word happens.
Pitch. It doesn't have to be. It's a simple question. Just answer it. It's not that complicated.
So this is why I just gish gallop, because people just avoid following the logic, so you can't even make your freaking point. What's your final point, Data? Just skip to the end. What's your final point?
So the point is can you have a horizon on an extended plane that's horizontal?
Possibly due to optical limitations.
Wonderful. That's all I'm looking for. And what I'm documenting here is this struggle
is there a point
for
here,
simple
or
questions
is it
like that to be
line of
answered.
questioning still?
No,
all right, yeah, so maybe
very
maybe
simple
Dave was
questions.
asking- yeah,
it's just it's another way for. Look how long
Right
it
on,
took.
comrade.
Hold on a second. Listen, he's not addressing the pencil question, though. That's the point here, guys. Look at him acting like he's doing something, and then he's going to take charge and take notes. But he's the one obfuscating from the fucking question. Let's all pay attention to that for a second.
I think Data did answer a lot. So re-ask your question, because Data did give a lot there. So Grim, you might have to re-ask it, because he was asking you.
No, all he did was ask the same question over and over again. He didn't do anything but ask the same question over and over again.
Grim asked me a question about a vacuum after I asked him. He never answered my question. He proceeded to, will we live in a vacuum?
I'm sorry, you're skipping the entire beginning of the conversation.
Try it again, Grim. One more time.
Enough. This is
try it again. Get back on the pony ride, bro.
Obfuscation looks like.
Get back on the pony
ride. I'm already on it, dude. You don't have to hand me shit.
So
I
here's
took
the
it
question,
from you.
Grim.
Right,
listen carefully.
Oh wait, no. The real question is,
let me finish.
Why aren't you
Please don't
addressing
interrupt.
the answer
Grim,
that you've been given about
you
the
never answered
apparent
me yet.
position of the horizon
Grim,
compared to the geometric horizon?
Grim,
why aren't you answering and addressing the pencil in the water example?
I'll answer it. I think it's a good point. I do think that there are effects like that happening. So boom, I'll say it. Yep.
Yeah.
Thank you.
There's land, and it does refract downward based on the atmospheric conditions. So here's the thing. Grim, answer my question, please. Can I have a horizontal path?
There's no reason for me to answer your question.
Can I have a horizontal, equal point of elevation, horizon line on an extended plane?
There's no reason for me to answer your question.
Grim, could you though? Like, would you have a horizon,
an
extended plane? Like, what's your?
I literally don't need to answer.
It wouldn't be a discernible
How
horizon.
extended?
You want him to answer
It
yours?
makes no difference.
Go back and forth and answer each other.
Well, you know what? It's been about 6 months though since I finally got an answer to my question though. So he can wait another 6 months for the answer to his fucking question. Eye for an eye,
how
dude.
extended is the plane are we talking
Literally
about?
been 6 months before, and I still haven't gotten an answer from him. I got an answer from you. So it's still sadly he's not addressed this.
You're whining.
No, I'm pointing out that you're actually obfuscating like the king of.
Why do you want an answer?
Wiping the floor with you.
Why do you guys want answers from each other? Wouldn't you just want to come to your own answers and then maybe just share?
Right, you're wiping the sky with me.
Yeah, dude, you can't even answer a simple question, bro. Let's try again.
Then just state your final.
Actually, I did answer it. Remember, this is a trick you like to do. When you don't like the answers that
you
you're
said,
given,
do we live in a vacuum?
You asked the question over and over and over again. No, I answered you before, and I said it on a sphere. I said on a sphere you can as well. Yes.
I'm sorry. Say again.
I said yes, you can on a sphere as well.
So
that was the first thing I said to you.
So
as well, like
so
also or TOO.
So to clarify,
how many different fucking ways do you need the right answer?
Okay, so to clarify, you can have equal elevation, creating a horizontal path on an extended level plane. How do you determine the difference? It's not
You're
a ball
assuming that
versus
reality
an
is
extended
a plane. I've already answered you so many times. It's ridiculous.
Your answer is refraction, right?
You're assuming reality. You're assuming
your answer is a pencil in a. Your answer is a pencil in a cup, right? That's how you tell the difference between a plane and a sphere.
Okay,
it's not what he said at all.
Even your own people.
Well, that's what his
can
demonstration was.
Now.
I actually want to hear again what Grim was saying. So Grim, explain the pencil thing, and
yeah, fourth time, Grim. Okay,
one more
fourth
time. This is it. All right. Yeah. The main point to what he used to ask all the time about the apparent position of the horizon compared to the geometric horizon, and which one is the one we pick and all this, bullshit. Like we're stupid enough to go for a dichotomy. And I said, it's both, obviously. And I'll give you an example of why. It's both because we wouldn't see in this pencil example, we wouldn't see the apparent position of the pencil at all had the pencil not been there. Same for the horizon.
Right,
We wouldn't see the apparent position. There's where he interrupts, right on cue. We wouldn't see the
I
apparent.
already agree with you.
Right,
that
right on
the
cue, just
object
like
is
a good
the
little
land.
bitch.
Yeah,
Right
I already
on
agree
cue.
with you. I already agreed with
There's
you
your
that
buddy,
it's
though.
refraction, and the land has to be there to refract. Absolutely. You also agreed to get a horizontal path. You can have an extended plane creating such. So how do you tell the difference between your sphere? You're claiming for a 6-foot observer
I
watching
never
another.
did.
Let me finish. You're claiming for
I
a
never
6-foot
did agree to
observer.
that. Not
You're
at eye
claiming for
level.
a 6-foot
Not at eye
observer
level.
has a guy running away 20, 30 minutes, and he's going to appear to go down from the observer at top of the sphere. You're saying that can happen as little as 3 miles, right?
Break out your theodolite because it's not at eye level. There's your difference.
Okay, so that's your answer to that?
I think what both of you guys are saying makes sense. And Grim, I hear what you're saying, like the pencil idea, right? So let's say a curve of a globe Earth. That would be the real horizon, and that's being refracted through the atmosphere. I get that idea. However, on a flat Earth as well, since you have an extended plane going out from you, you do have the optical extinction point of the sky and the Earth, and whatever that is can also be refracted, as we see in looming and stooping and phantom organas and all of that. There's definitely warping and things that happen. So what you're saying makes sense as a concept,
true,
but it could be seen in both models essentially.
Well, right.
I think the difference
there's some
Here's the
distinct
problem
differences.
with your
There's a
globe
couple of
model.
distinct differences.
Right, there are
One,
differences.
Here's the
and
problem with your globe
one,
model.
excuse me. There's a couple of distinct
Grim.
differences. Is the
Yeah.
point. And
I'll
for
tell
the
you what
first
the distinct
one,
difference is.
oh wow, this guy doesn't
Yep.
want to know about his fucking
Let's let
flaws
Grim,
in his own model.
Grim, what's the
I want to hear why Grim thinks that one is makes the difference on one model or the other.
Okay, so the base of the mountain is actually much closer to me than the top of the mountain. That's one problem. We can still see very clearly the top of the mountain. That's another problem. Shadows upon those same mountains in those locations that we've all seen. Shadow, light under clouds. Those are the same things that we've all seen.
The original thing you were trying to refute that I said is you were talking about the pencil and the horizon and how that you have that warping and everything. And what you were going to respond to, which is why I wanted to give you the chance. You were saying no, there's a way that happens that it's a globe rather than a flat plane. Because I was just saying that it can be that idea could be seen on both models. There's actually reasons I could say to know it's a plane, but I won't do that. I'm asking you. You made the claim. No, there's a difference, but then you didn't actually answer that. So
at the first, the first one was an actual answer. The first one was an answer. Yeah, the first one was an answer. The first example was a very clear answer. The top of the mountain is further away from me than the base of the mountain, which is much closer to me, which I cannot see the base of the mountain at all. But I can see the top of the mountain.
On a plane, you wouldn't expect to do that due to perspective if it's too far away from you. Just like with you're on a
absolutely.
You're on a chessboard, you can't see the little squares forever.
Graham, that doesn't address the main.
That much of the mountain would not be missing. I'm sorry, you were talking about a mountain that's nearly a mile high.
Hey,
Graham, that doesn't address the diffraction limit from the level of the eyes. Looking down a hallway, you see something very particular happens at the level of the eyes, where something above the level of the eyes appears to ramp down and sandwich, with whatever is below the level of the eyes ramping up, leading to a sandwiching zone where everything compresses. What you're saying doesn't address that. Did you have another problem or whatever?
I can clearly address that. I can clearly address that with a camera. You don't need your eye. There's no level of the eye in your camera.
Further out, but there's still convergence at the level of the camera.
It's not a round sensor on the camera.
We're not looking at it. We're not looking at it at the level of the sensor. So since you can't address that, do you have anything else that you'd like to address? You can't address it, so let's move on.
No, I'm addressing it. You're overdressing it.
Addressing it adequately.
You're literally overdressing it.
Not addressing it. So let's move on. Is there anything else?
Why do I see stars clearly way past the horizon if everything's squishing and squanching?
Obviously, because they're higher up and at a wider angle. Anything else? And also, as you know, lit objects break angular size rules and can be seen for much longer than they would be if they were not lit. Anything else?
If I stare directly at a star, then it's in the center of my
Well, for one thing, but then it's higher up and it's at a wider angle, number one, and number two, it's a lit object. Anything else?
Oh, that's terrible. You have another answer because that's not very good.
What you're saying
Anything
doesn't
else?
address it, so we're gonna have to agree to disagree. If that's it, then
Well, your
anybody
answer.
else?
If your answer is all, if that's all you have for an answer, then I guess we'll need something else. Anybody else?
I think that a lot of people are talking at the same time, but I hear what both of you guys are saying. So, yeah, I mean, this could be seen in different ways. Let me ask like a globe earther just to kind of start a new topic. Like in terms of the effects that we get with long distances, why is it that we can see so much further than we should on a globe? What's going on there? If the fact that we just see way, way, way further than we should with a globe that has this type of curvature. I'm wondering how you guys could say that's possible.
I have an answer. I'm a glober. They'll tell you now I'm a glober.
Sure.
But
this happened.
I think that the thing is magical moments would be the answer.
Okay, Emerald, do you want to have a crack at that one?
Oh God,
It's going to be a refraction. Who else going to crack at it?
Special.
Hey, how about this? You can't even refute it. God wanted you to see further on the globe.
I guess I can. I can hijack this image.
What?
I'm very aware of
this answers other than refraction. Okay. Anything else?
Yeah, a quick one for Don.
Anything else?
Don, you haven't
Those
reached
were
the
good enough.
status of Glober yet. You've only reached the status of majorly confused.
skeptic.
God's still with me. God's still
So
with
every
me.
time I
How
hear
about
like I can see farther than I'm supposed to be able to see, I keep somebody gives me some sort of an example of something they're not really that clear on.
No, we see exactly as far as we're able to see and no further.
That's what I mean. But this data, like they'll be like, "Oh, I'm probably at about 6 foot here," like, and that's probably about 200 miles away there. And this is probably.
To be fair, to respond to that, I do hear what you're saying. However, I've been in this discussion for many, many, many years. I personally have seen, validated, witnessed, and have data for literally thousands upon thousands of observations all around the Earth at different locations, every continent, every land, long distance landmass. Not every one that exists, but many, 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 on all oceans and all different parts of the world. And whether you use a binoculars, telescope, naked eye, there's a consistent.
What about infrared?
Let me just finish this thought. There's a consistent and infrared, but there's a consistency of the distance we're able to see that indicates the absolute planar nature of the Earth. Like it's not just one image that's being bent in a certain environment. Every observational point always indicates a level surface and the function of perspective.
I have never seen a photo of an observation that cannot be explained by the refractive index of our planet.
Wait a second.
So the refractive index of your planet assumes a radius, so that whole thing is assumptive. It actually doesn't.
I don't care.
So what?
I don't care what your bias is.
With
several hundred years of
no, why can't we see forever with infrared then? We should be able to see like forever, bro.
Infrared just has a different refractive index to light. I mean, light all bends at different rates depending on its frequency.
So if that's your quality of discernment of coming
blue light is
more plugging in a radius, then I hear you, but that does not do it for me.
If that was the be all and end all reason of why I think the Earth is red, you might have a slither of a point. To be honest, photography is weak ass evidence because you don't know the exact conditions of the day, you don't know exact distance to your object of observation, you don't know your exact elevation. You know, there are lots of variables that are going on there. So measuring shit is how we determine stuff rather than trying to eyeball it.
Looks like a laser.
Again, a laser bend.
That's not very good either, buddy. It's light.
Actually, I like sort of optical surveying.
Better.
It's a good way of doing it because we've already got the refraction taken into account, or standardized refraction taken into account.
The only problem is you have so many rubber rulers, you can't determine anything with your models anymore. You just make
you've got a deviation
ladder.
You've got a plus or minus
account for the refractive effects
range of
necessary
error.
for you to see at the distances that you're seeing over the ball hump of Earth curvature. So it's really hard to trust this model at this point since it has so many rubber rulers and workarounds.
Not really, because
can I remind Lemon one thing? Remember those experiments where we show, refraction in the aquariums, and what we use to show the refraction is a laser, it bending all over the place. So I don't know why you keep going for a laser to try and show your straightness, because you know for a fact lasers bend all over the place in the
You don't bend at 8 inches per mile squared. That's absurd, and you have to use absurd amounts of sugar water to get it to do so. So that's not.
Graham, oh my God! You just need the distance.
Graham, I've actually done
distance.
Graham, I've actually done laser tests in person. I just wanted to ask if you have, because although lasers can bend through sugar water, that's a very specific, very dense, particular medium with like synthetic sugar, which is very crystalline. So that's very different than what the air is.
Agree.
And when I've done laser tests, I'm just telling you from my own experience, they're not bending. They are straight over the earth.
They absolutely do. And that's the whole point of it. Is that
they diverge as well, right? They spread out.
They diverge extremely.
Of course it does that.
Laser that
you can have a proper collinator on it to make it go farther, longer, and that your Earth doesn't curve 8 inches per mile square is the point.
Or you can break one, like if you could it and still find the results.
The one with the proper, calibrator or whatever on it.
Yeah, collinator. They break it. They broke it in shipping. They broke it in shipping.
It, and then you use the other one, and you had a 10-foot fucking diffusion or better. And you're like, look, I'm picking up some laser light, but it's like, okay, but you're picking up a 10-foot diffusion, which is literally refracting at least several inches to a foot.
Who are you talking about?
It was the 21 foot circumference.
The only flat Earth experiment we can.
Which one are you talking about? Are you talking about?
So, Geo, excuse me, Geo, are you saying laser light acts differently to sunlight?
Waz, what's up, Waz?
Yeah, just g'day. Are you saying laser?
Who the fuck knows? You can't fucking manipulate the sun.
You can the light though.
Lasers and sunlight, like when you reflect sunlight with a mirror over long distance, that's shooting straight. Yeah, like if someone's across the beach flashing sunlight at you, I understand the Goldberg belief that it's all
flashes sunlight at you.
The thing is that like you'd have to believe that it's always doing that, like in a consistent way, because every time we observe it, it's always level and flat. Well, so if it's curving, it would have to be doing it perfectly to make it look flat.
Again, it's not. It's measurably not flat. It's observably not flat.
How have you measured it not flat?
And geodetic surveying, angle of elevation to Polaris, both show the Earth is curved.
Using the sky. I'm talking. I wanted to know. You said
exactly. No. Geodetic surveying doesn't use the sky.
It does. It uses
one land-based, one sky-based.
It uses the horizon.
Both coming. Sorry, can I finish my point?
Yeah, sorry.
Both coming to the same conclusion. So we have multiple observations. It's not we have one thing that says the Earth is a globe. It's like we've got this smorgasbord of
Then
choice.
we have the sky.
Yeah,
then
is
the
it
moon
true?
and the sun. And then the moon and the sun behave the way they do, which we would only really see if we were either spinning or going around this thing really fast, or if it was going around us. Something's got to be going on there. And so you start deducing, what would it be? Would it be me moving around it? Then if that's the case, then it and that must be at the same distance as the sun. You start trying to work all this stuff out, and what you end up with, the only thing that could absolutely work is what we end up with. It's a sphere with the moon going around the earth and the moon going around the sun.
Well, the thing is, Waz was talking about the difference between sunlight and laser light. A laser is a collimated, concentrated, shaped beam of light that will burn your eye out if it reaches your eye. Sunlight is diffuse and doesn't appear to have as much of a shape. Perhaps it travels in a similar way, but it doesn't burn your eye out, and it doesn't have a shape that can bend like that. It appears to be more of a diffuse sort of illumination that fills the medium. So we have key differences here that can lead to equivocation if we're not careful with this laser in sugar water that does not behave the way that soft illumination and sunlight would behave in the medium of atmosphere or whatever the hell that we're in, that is completely filled with illumination.
One very quick point. If I take you out and I pin your eyes open and I lie you down under the midday sun anywhere reasonably warm, it's going to burn your fucking eyes out.
If you're looking directly at the sun, sure, but if I'm looking at the objects that are illuminated by the sun, that's not going to be the case. So we have
and in the same way, if you take a
that it's
laser
not
and point it
something
at a
that
wall,
solves the problem.
That's not going to be the case.
That is the case.
So
You
they
can
act,
look at a white
they
wall
act the
and then
same,
you're
or they
right.
act differently in the same medium?
You guys, hold on. Everyone's talking at once. Waz,
Yeah.
go ahead, Waz, because Waz was going to
So,
respond.
so do they act the same, or do they act differently in the same medium?
Obviously, yes, a laser does not fill the whole medium. Sunlight and illumination does. That's a key difference right there. You have one that can fill up the whole medium, the other that cannot.
Yeah, but they're using an optical culminator to focus the frequency of light, right? And through the process of magnetic electromagnetic energy, you can use the culminator to propagate a single frequency beam, and that beam can actually be controlled based on its culminator quality, size of the output of the magnetism, electromagnetic frequency. If you can control those two accurately, you can get a straight line of sight well into 161 kilometers. Easy.
Yeah, well said. Everything you said there, I hear what you're saying. I absolutely agree. I was just thinking when you said that, the idea that the sun is a collimator, that the sun itself is a collimator of potentially like pure energy or some kind of energy beyond this world, and the sun is just collimating the light from the beyond, although it's not, focusing it into a beam the way a laser does, but like Lemon was saying, it is more diffuse. It propagates through the medium. Obviously it has like the infrared, the warmth to it, the ultraviolet, so it's different than laser light in that way. Whereas lasers, like you were saying, culminated, focused electrical energy essentially. But I like that idea of the sun being a collimator.
I think the word is coherent.
Conclusions there.
So
this
are you-
the energy
light.
and sorry, was gone.
So are you saying that sunlight refracts or doesn't refract, i.e. bend, when it comes through the atmosphere?
Obviously,
does.
it
Of course it
refracts.
does.
Grim, were you saying something?
I was just saying it's coherency, I think is the word you guys were looking for on the light. The similarities between the laser and the sun. Coherent light.
Good one. Yeah, that's true.
Semi-coherent.
Yeah, and the polarization of coherent light changing the. Yeah, I like that.
That's just all I got for it. Go ahead.
That's one of the cool things about
sunlight bending this way, and we're in an illuminated medium where everything is bathed in gentle sunlight. It doesn't have. We're not looking at objects that have lasers coming off of them, burning our eyes. So there appears to be
Easy with the
a bit of a
toxic
difference here.
femininity, bro.
But
I'm
again,
just kidding. Go ahead. I'm just playing, bro.
Just saying.
It's a good point,
ray of
actually,
light.
but I hate it.
Okay,
I had a conversation last
Is that
night
Dross
with
trying to
someone
talk? I'm sorry, man. You're
active.
breaking up.
Oh, I know.
Oh, no, that's Demon. Oh, yeah, okay, there you
Yeah,
go.
the only thing I want to say, the only difference between a laser beam and a ray of light from the sun or another source is the laser beam is a single frequency generally, and it's been focused. It's focused in a similar way that I can take a torch and I can focus that beam. It doesn't change the refractive properties of that frequency of light one fucking bit.
But it has
so
it
red
has
laser
diffraction
will
limits
refract
and it
a
has
lot
refraction
more than-
limits.
Yeah, and
Light
obviously
does not
still
have a
refracts.
diffraction limit, and a
It
refraction limit
refracts.
isn't a thing.
And it refracts in
light
the space
has
that
a
you're
There's a
using.
limit to
Sure,
refraction,
100%.
is there?
If you use a 700 nanometers, it has a certain diffraction limit. If you use
Given an aperture, it's not like the light itself. It's
the
not like an inherent
optical
property of the light.
culminator is the aperture. Or not the aperture, it's the lens. So you're shooting out that lens. The light still has a propagation to its electromagnetic potential, and it's.
Does it change?
What's that?
Does it change the effect of refraction in an atmosphere for that frequency of light?
It can. It can. It
And
can.
if it does, I
No.
would like to see some evidence because that's not how
It
I
doesn't.
understand it.
That's not how light
Frequencies
works. It
frequencies
doesn't.
of light have refraction and diffraction effects. Yes, they
Yes.
do.
Well,
That's
they
correct.
have refraction.
But the question is, does laser light behave of, let's say, 500 nanometers
No, it doesn't
behave
change the
differently in
frequency.
a refractive index
It's the
compared to other
phase.
500 nanometer light?
What do you
And
mean other
are-
500
Coherency that
nanometer
the
light?
laser light change.
Like if we compare it to other arbitrary light of the same frequency, does the fact that it's been collimated and made coherent affect how it refracts compared to other light of the same frequency? I think
Well,
my
that
understanding is
depends.
not.
That depends. That depends on what it's interfering with.
Yeah, I would say absolutely. If you have a different source, it's going to refract differently than
through the same medium. Through the
yeah.
same medium, it'll bend the same. That's the issue.
Ideally, but that's what you use different wavelengths of light, because different wavelengths of light have different refraction and diffraction properties.
And that's why I said that if we use the same wavelength of light, the same frequency of light as we're using in the laser, it's going to have exactly the same.
But that's why you do infrared. That's why you do infrared.
Reaction that we have.
That's why you do infrared, because you have less
and
diffraction.
Infrared still will refract at that
but at longer distances.
In exactly the same way
in longer
as
distances,
an infrared laser will refract.
In longer distances, yeah. And that means when you use use different.
He's not
I
listening.
agree with you. Different frequencies bend at a different rate.
Yeah.
What I'm saying is that whether the source is a laser,
if you want to culminate a frequency,
I just want to finish my point. Whether the source is a laser or a ray of sunlight that contains that frequency, they will bend exactly the fucking same. The same wavelengths will bend in the same way.
Sure, but I'm not talking about that. So as a designer, like for instance, you want to do radar, okay? You want to make a radar gun.
Why are we
Let me finish.
Sorry.
Let me finish, please. So you want to make a radar gun, right? That radar gun is going to have a culminator on it. It's going to have a frequency of beam of light based on the size of the gun, essentially the size of the culminator and the output of energy. That beam should go a certain distance, right? And before that distance ends out or ends its propagation, it will diffract, right? So the issue with radar guns is if they're not used at the proper distance, you won't be able to tell the distance between two cars at a certain distance, right? So you can shoot in a straight line effectively way past the distance of 8 inches per mile square. And a radar gun, in a version of a radar gun, is the same principle. And the idea is to have the least amount of diffraction at that distance so you can tell two objects apart.
I'm sorry, I know all of that because coming through.
Dude, radars can't see over the horizon either, man.
I think what Data said, I just want to point out, I think that was a really good point, and I
know I missed it, which is really annoying.
I missed
you
it
can
too,
go back on the live
obviously.
stream and listen to it because it was
I swear.
it was spot on.
The laser also has an opening. A laser has an opening and an aperture through which the light is focused. So that's going to shape and make the light travel differently than gentle illumination coming from all points on the object. So unless you're saying all of the light is coming from a hole in the object similar to a laser, we have serious equivocation here.
But that's a property of where the light has been emitted and what direction it was sent, not like a light inherent property.
Hello.
Hello. Sorry.
Yeah, you want to?
Just let me mention something about radar. I've got to jump off in a sec. Just one thing I've been waiting to try and get out. I had a conversation last night with a guy who's in active naval service in the Australian Navy, and he said that they've got line of sight naval radar that can pick up surface targets at 50 to 60 miles. Now, get on your Earth curve calculator. That target should be 1,400 feet in the shadow of the Earth curve. But line of sight, not any other sort of radar, line of sight radar can pick them up 50 to 60 miles. How would that be explained?
Well, what was his answer when you pointed that out to him?
That's actually
the height of the radar.
Great. That's actually incredibly common, and actually even railguns shoot up to 130 miles line of sight, and even further distances. So I mean,
okay, how about this, gentlemen?
That's fine.
The Earth is flat, but not everyone's.
Do you know what weather radar can go? The distance of weather radar, straight path line of sight, weather radar. Do you know what the total record is?
I'm trying to get an explanation on a naval radar from the globe side.
I know,
a guy I know firsthand who has spoken to an expert in field, not some schmuck on the boat, but expert operators who they can't explain it to him how they can see 50 to 60 miles surface to surface. So that's an anomaly that you can't just hand wave away, everybody.
No,
Yeah,
here's the best part. You can go fact check this. Go look at any.
Hold on.
He
was addressing a globe earther, to be fair. I mean, he did want to.
Don't segue into something you want to say. I want to get an answer from the other side.
Sorry, my apologies.
The answer, I mean, the best answer would come from Alan Evans, who's an ex-radar technician, used to work on, dishes that are like 60 feet wide. So if anyone's going to be able to explain how the radar signals work, would be him. That would be the most accurate. So keep that in mind if you ever speak to him. But if anyone else has got
just everyone, if everyone could just keep in mind that nomenclature, it is called a line of sight radar.
Yeah.
I know there's other sorts of radars that bounce around and do all sorts of interesting things, but naval terminology, this is a line of sight radar, and it's a bit baffling.
You changed your story, by the way. You first said that you spoke to the individual who is the radar technician, and then you changed it to where you talked to a guy who had talked to somebody else. You're going off of a story.
Let me be clear. Okay, but if you want to be a smart ass, let me be clear. The guy I speak
by pointing out what you did. I'm sorry.
The guy that I know personally and have done for 15 years is considered an expert in field on his naval vessel, not in radar, but in a very closely allied area. He works very closely with experts in field on his naval vessel who are radar experts in field, and he has asked them very specific questions. So there's the whole story. I did abbreviate it for the sake of time, but now you know the whole story.
Your brother's sister's girlfriend's cousin told you something. That means nothing.
You can hand wave it away if you like.
This conversational turd also belies the fact that you guys have no answer. So I guess we'll have to wait for this and whatever the name is to get a answer. So thank you very much. What's the next topic for discussion?
Can you guys hear me?
Well, to back up what he's saying,
what were you saying?
Yeah. Well, hang on.
So almost every one of the 50+ U.S. Navy ships that this man here sailed on, who I'm quoting, has installed an average marine radar from a manufacturer like Raytheon or Furuno. These tend to be fishing boat radars with ranges of 25 to 75 nautical miles, depending on how high above the sea surface they were installed. Why would the U.S. Navy have a commercial off-the-shelf marine radar? Why wouldn't they? If almost on every ship they sail, because often you don't want to see, you don't want to power up that big, beautiful, I can see everything radar and tell the whole world, hey, U.S. Navy ship, warship right here. I don't know. So I think they could have much more powerful radars and put them up even higher, but they also act as beacons to enemies and give away your location.
Can you back that up?
I think so. I think it's just how high it needs to be.
That's not actually what he was saying, and what he was saying to refute that observation, in my opinion, would be basically a void of really knowing the amount of data that's out there of all kinds of things in terms of like seeing further. We can see all like not only radar, but there's many other tests that have been done as well in terms of like rail guns as well. There's so many. So the thing is that what he was really trying to point out is how can that be explained to exist on a globe Earth?
It's a story. There's no need to offer any.
Okay. Well, let me ask you this. Let's say that it was verified by your awareness, like you and I did it. It's verified. Let's say it's true.
You're still just that's an in run around going over the story. It doesn't work that way, dude.
We're on Discord, so we can't be in person doing it. The thing is that many military officers in many fields have even been on different YouTube podcasts and things describing and admitting these things, how far they can shoot rail guns, line of sight, radar, all of these things. So are you just denying that those things exist and that there's a curve, or are you saying there's a reason that they're happening?
Nobody's denying they exist. You're using them in the incorrect way.
How can you describe it on a globe
Make
Earth?
a different kind of statement out of it. Because here's a pilot here, Patrick Binder, Fluid Dynamics Engineering and Research. He has 100+ R&D papers, and he says there's no average radar, no Navy air search radar has equipment-based range limited for detecting aircraft. The limit is the horizon distance. For air-breathing targets, i.e. flying with the atmosphere, air search radars are limited by the horizon, how high the antenna is mounted, and how high or low the object is flying, typically anywhere from 25 nautical miles to as much as 250 to 300 nautical miles. These are
okay. So you're saying it's how high it is. So let's.
You're not real. Other than saying it's how high it is, you didn't really address his claim that
Well,
of
the point is,
the
it's
radar
not
on the
such a
ship is
strange
going to
thing
be
for
what,
a radar
100
on a
foot,
ship to
maybe
pick
100
up.
foot off the deck. That's all you got to
No,
work with.
they can
100
lift
foot off the
them.
deck.
And that's still too low because you need 50 miles. You basically need to set up the equation. 50 equals 1.22 times the square root of the height and feet above the surface.
I was on the
and
hang on, lemon. I was on the Earth curve calculator. If you put that radar dish 500 feet,
You guys
off
are only
the
hearing
deck,
what you want to hear, right?
the thing.
You didn't hear
I'm
the
using
part
your
where
calculator,
it's also
dude.
about
Not
the
mine. It's
object,
yours.
how high the object is flying.
Peter,
It's
you are
about how
so
how high the object
willfully.
it's looking at is flying. It's two things.
It's
How high
it's
the
a
antenna
surface
is.
target.
If you're
It's
trying
not
to
an
too low off the
airplane. Did you
ground,
not hear
Grim.
me?
well, not for what this man's
Too low off
talking
the
about.
ground,
surface
Grim. He's
target.
He's
basically
talking about
getting to it being
distances
too
at
low off the
300.
ground. Let him make his final point with the numbers. What were you
Yeah,
saying?
is a surface target on a mountain?
It's on the
That could
ocean.
help.
It's a boat.
Like, I don't know. I'm not looking
It's
at
a
your. I don't
boat.
know what you're talking about specifically. I'm talking about what this man's talking about that I'm reading from right here. That's why he's talking about these distances from 250 to
I'm talking
300
about
nautical
naval
miles.
vessels, surface to surface naval vessel. What are you talking about?
Well, a naval vessel, surface to air and to surface. He's talking about from
No, I'm
25
if you listen to
depending
my original story,
upon
it
the
picks up
horizon.
a surface target. Surface target, not air target. Surface
Yeah, you said
target.
that, and I covered it in my first part of his statement when I said there is no average air radar, no Navy air search radar has equipment-based range for detecting aircraft. The limit is the horizon. For
And the
every
horizon's
So if
too
the
low,
target,
Grim.
if
That's
a
the
surface
point. It's
target
too low
is
to the
50
ground.
miles away, your horizon is going to be way obstructing that radar.
Yeah, but
Well,
a lot of
Relton's
times
used a
you'll get
ballistic
not
flight
if the
model.
radar is up higher.
So
a lot of times. Guys, can I just say
And
one
if
thing?
it's
it's on a ship.
Guys, a lot of
100
times
feet in the air.
Guys, a lot of times they'll get their target from a secondary source, like a plane or something that's in the air. That will give them a target. Paint
Yeah,
the target, and they'll
I
use
guess
that.
the experts on the ship don't know how their radar works. I guess that's
No,
my
here.
bad. Sorry, guys.
I worked radar. I worked radar on the F-15, on the C model, particularly air to air, and I can tell you that the AWACS is typically what they're going to use for very long range shots, because although the horizon is blocking the line of sight of the missile itself, you can still launch the missile in a particular direction, and it'll use the information from the AWACS and the radar that it can see to target the missile.
Yep.
Yeah, I guess these experts on the ship in the Australian Navy wouldn't know that.
Dude, why do
they
you
were
think they
bouncing off
stick
an
a
aircraft.
plane in the air?
Have your answer, dude. It's not hard.
You also have different types of missiles, and you have missiles that can utilize different types of targeting. So it's all kinds of things. It's not just all missiles are radar, line of sight. All missiles are infrared.
I'm not talking about missiles. I'm not talking about missiles. I'm not talking about missiles.
Railguns, same thing. Same thing. Railguns, same thing.
He's just talking about a story he made up that everybody's supposed to get involved with.
Well, these are some very nice
No, he didn't
excuses
say-
you guys are talking about. An airplane giving them the sight on the radar. You're saying that it has to be higher up, even though it's on a ship or something that he says is like 100 feet or whatever. Some very nice excuses. So we need to see what the actual conditions are and whether there's a hump of Earth curvature in the way or it's more like a flat plane.
Lemon Bird. It's a third-party story.
That's how it works.
But I want to comment on what Scott said. Scott, I do hear what you're saying. I think that's a valid point in terms of some of these observations might be from high altitude, other sources in the military is what I'm saying, when you're doing things. What he was describing, he was talking about a transmitter and a receiver at ground level, surface level at that 60 miles, and also railguns. So Scott, with that being followed up, how would you describe a railgun? Because what my older brother would say, he's a heliocentric guy. What he would say is that the projectile is actually dropping, around the Earth due to gravity. Is that what you also would say?
Yeah. They fire the railgun
it's a parabola.
at a parabolic arc to get over the horizon, and it'll drop just like an artillery shell. It'll do the same kind of thing.
Around 120 miles will put a projectile over 25 miles high in the atmosphere. Next.
So you also would.
The question is, how do they aim that?
No. I've looked at the military statistics and I've actually examined the documents to go around it. So, to the best of my knowledge, with the released information we have available, that's how a railgun works. It's not point to point. That's a stupid thing that flat earthers and other people that don't do decent research came up with as a totally stupid point to make.
But
Actually
you're
heard military,
implying
like-
projectile motion and a parabola-like curve or whatever over long distances that's even less tenable. I mean, it would be increasingly off depending on how high it's arcing in the air by your implication. That's ridiculous.
Right,
How
you
can
just
you
use
sure
math.
No, we've solved the problem.
all you
We've
need.
solved the
That's a really
problem
good
of aiming
That's
at
a
things
great
that we
point.
can't see. We have solved that problem years and years ago. We have all kinds of methods that we use to target something that is beyond our sight, right? We infrared paint targets. We have all kinds of techniques we can use. So I assume all those techniques would apply to a railgun too, just whichever one is appropriate for the time.
What Lemon was saying was very valid. I mean, that idea, for example, like when you throw a football, you know, the football arcs, we all know that, the basic physics of all of that. So the idea, if you have a railgun across like a globe Earth, is you'd be shooting it out. And I know what you're saying. You'd have to angle it and you'd have to calculate that. That makes sense. And as it would start falling. Now, like I said, what someone like my brother would say is he would kind of say that it's almost like gravity takes over. Like it's not just the arc of when you throw a football, but that there's almost like something else going on. Yeah, it doesn't resonate with me as being the case, but it is an interesting way to describe it. But like Lemon was saying too, if you had that at different angles, it wouldn't always arc perfectly around a globe. It would be arcing due to the exact angle that it's shot. And anyways, yeah,
it's not following the curve of the Earth. It's following its own parabolic curve.
It happen to be the same. Perfect.
No, they're not the same. No, not perfectly the same at all. Because as I say, it gets an elevation of about 25 miles at its peak at about 100-mile hit. Or it's 100 kilometers and 25 kilometers.
That would be the case.
But
On
a
a flat Earth, you would have to angle it up, and it would have to parabolically arc. So it would still do a parabolic arc on a flat plane. Yeah.
Yes.
And it would do the same thing on a globe plane, on a globe Earth.
Yeah.
If the Earth was a globe, yeah, it would do,
a globe.
But it wouldn't, in my mind, it wouldn't go like all of the idea of like the way, like you guys maybe thinking lasers or long distance observations are all bending. To me, it doesn't resonate as making sense that everything would be bending perfectly parallel to this globe Earth to make it all look level and flat and stationary.
That's why we have mirages. That's why we have deformation in the atmosphere.
It just doesn't resonate to me, but I do respect your viewpoint that that's what it is.
I respect
you
your
are right that it's not all following the arc. You are right that it's not all following the arc of the Earth perfectly. It doesn't do that. So your intuition it doesn't is I think correct.
Gio, do you think that the railguns are mounted like you did in your meme?
I've never been around one in person. I think what my understanding is that they're mounted on vessels, large battleships and things,
No, I got that part. No, the way it was mounted, that whole, like, parallel to the deck.
Okay, I didn't make that meme, but I had it in my thing. I'd have to look at, that one looks like it is mounted on the deck. Whether that one's whether that one's set up for use or whether it's being
not
transported, I can't tell.
The giant cap at the end of the barrel kind of gives you an idea.
An idea of what?
That it's not in use.
I guess I can't really tell. I mean, it looks like it is bolted down there, but it does have some hazard things. Yeah, I didn't make that meme, but in general, these railguns are mounted on vessels over the ocean, and they shoot the projectile.
Yeah,
and like
I got that part.
Over a flat Earth or a globe, it would still follow a trajectory due to physics and so on. The question is whether the Earth is actually curving away from, that location to where you would have to sort of incorporate that, into it.
I don't think
what physics though.
Kosho's made a little point, which I think is right, which I don't think they're actually in production on ships yet. I think we're still in the testy phase.
This idea that there's hundreds of ships out there with these mounted is completely fallacious. They're still very...
You said it would follow a trajectory based on physics. Did you pick up on that?
Yeah, just like everything does. If you throw a football, I mean, there's the physics we all experience and can observe, and there is a force involved.
How's that physics work then, mate?
Well, my viewpoint, you've got the electrostatic field of the Earth, and then the electrostatic dynamic, the Earth static component of the physical matter, and then you have the electrical system, the battery of the Earth. So you have the ground, which is the Earth, which is the ground, the sky, which is the positive. And within that field, there is a static force which causes things that are heavier than the air and have a positive attraction to fall towards the Earth, and then things negative will go towards the positive sky. So if you're talking about gravity and all that,
But I can ionize
not the
helium.
physics that everyone knows and agrees on. Not that physics.
But I can ionize helium, or I could ionize another gas, and it would still go either up or down based on its density. So the positive or negative charge seems to have zero effect then.
Completely nonsense, Geo, because if it did follow a charge, once a falling object hit the ground, the charge would be equalized, and the thing would then have an apparent different mass to when it was falling. And we don't see this. We see a constant force of 9.81 meters per second squared on all objects falling downwards.
That's right.
Well, that the 9.8 meters per second, I mean, that's debated whether that's always the case, but
it is. I measured it in school.
Honest drag.
But what was the? I was going to actually
to within tolerance. Like it's not always exactly that.
Oh, the original thing. Okay, the charge thing. Okay, well, let me just say, in my view, I'm just sharing this all from my viewpoint. I'm not trying to convince anyone else of it. But to me, when I say electrical charge of matter, I'm not talking about the same spectrum. Just like there's like ultraviolet, infrared, there's different visible light parts of the sun. In my personal viewpoint of how I understand reality to be, physical matter has essentially it's like an Earth static spectrum, and that Earth static spectrum denotes its buoyancy and density. It's connected to buoyancy and density. And it's connected to physical matter and how that functions in the Earth system, which essentially I think is a battery. It's an electrical system. So the static is not the same as if you necessarily just put your finger in an electrical socket. However, there is a similar, like a Van de Graaff generator can make things become anti-gravity, and there is a static quality to this Earth static effect, the same way that like dust will like cling to like a tube television, things like that. So there is a static cling component going on, but that actual charge is what is connected to the buoyancy and density and then to the ground and the sky, and then that positive or negative gives it, that essentially attraction up or down in addition to...
Okay, now, Geo, quick one. How much static charge is required to draw a particle of dust to this CRT screen?
Well, one pretty cool little model you can do, which Good Times for All did it. You take two metal plates and you hook a Van de Graaff generator up to each side. Take a little sheet of paper, put it on the bottom plate, and the top plate is maybe 4 inches above the bottom. And then fire up the Van de Graaff generator. And once you give that static charge to those two plates, that little sheet of paper will go anti-gravity and it'll stick up to the top plate.
I understand you're talking about the movement of something due to static, but I'm asking you how much charge is required.
Well, that's interesting. I mean, I guess when you do like a balloon on your hair, all you have to do is rub the balloon. I mean, there's that idea. I'm not saying that's exactly.
I've done that myself, and so have my kids. But I'm just trying to get from you how much static charge is required to move a particular type of mass.
That's a good question. You'd have to have a way of applying the spectrum of static charge that I'm talking about. You would have to have a device or an ability to do that, which gets into anti-gravity devices. Do the military have them on and on? UFOs and everything do that.
But you have when I asked you about physics earlier, you gave me an explanation. So you must have some way of working out how much static charge you need to move a specific amount of mass, right? You'd have to have that, surely.
Well, yeah, we can get into how they built the pyramids from there.
Well, we don't have to go that far yet, but I mean,
we could go deep in terms of how they've done.
We're talking about moving a dust particle.
How much do you need? Well, I guess it depends. Well,
that's right. It depends, and that's what I'm asking you.
How much do you need to make something become anti-gravity, you're saying?
No. How much static charge do you need to move a mass?
I guess it depends on what the mass is made of and its size and the medium.
Yes, they are the variables. Yes, correct. They are the variables. So what is the formula to work it out?
Well, I don't know that there is any one formula because each one is going to depend on what the matter is. I mean, if it's water, if it's dust, if it's other things. So it depends. There's not just one formula. Yes,
they're all variables. That's right. They're all variables that would be in a formula. So you're basically, your physics doesn't have a comprehensive explanation.
Explained exactly.
When you compare it to real physics.
He explained very well how he has misconstrued the physics of reality with this nonsense of a spectrum of static charge, which simply doesn't exist, but he's just ignoring these obvious facts to try and generate his false paradigm to live in.
I hear you. I hear you out. Yeah, thanks for sharing. I'm open. Yeah, Waz, anyone else? Yeah, if you guys want to share what you think. I think there's a lot of formulas that work with, if you want to call it gravity, or, there are interesting ways in which mathematics lines up. But yeah, I mean, if anyone else wants to share what they think, I'm all ears.
Why didn't the plate float?
Minor details.
You mean with the piece of paper that clings to the top plate from the bottom and vice versa with the Van de Graaff generator?
Why didn't the plate float?
Well, I think that when we use static charge, like if you take a balloon and you rub it on something, you do it with your hair, or when you rub your feet across a carpet, you touch a doorknob, or in this case, the Van de Graaff generator is essentially similar. I'm not claiming that that's exactly what gravity is. I'm not saying it's on that spectrum. So I'm not just saying if you put a human between two plates and you jacked it up that they're all of a sudden, I mean, you might get a human to do that if you did enough. You'd probably kill them in the meantime. I mean, don't they say when people get shocked by lightning, they jump off the ground or whatever?
Your claim is that this is all happening naturally.
Well,
right?
I guess what I'm trying to say is that the actual the Earth static effect that I'm describing is not the exact same as rubbing a balloon and putting it on your hair, but I'm using ways of trying to elucidate what to try to describe it in that sense.
You seem to be having issues when specific questions are answered or asked. Sorry.
We've come to an impasse as to how you can explain what you think's happening with static charge. So maybe we should explore something else momentarily. Can I get?
Well, no, I think I've described what I mean quite well. What I'm saying. I'm not trying to ask other people to believe it. What I'm saying, I know for myself, my own claim. What I know is that there is a spectrum of static force that is connected to matter and is connected to the ground and the sky. And with those three, you get the medium that we live within. And that, to me, is what causes the physics of matter.
What is the scale of this spectrum? What are the units along the, if you were to graph this spectrum, what would it be measured in?
Well, I think we're on the cutting edge of getting closer to that in terms of discovering that. I think that the ancients may have had more knowledge than us.
I don't know.
I think that it's interesting to
I don't know, mate. That's what you need to be saying.
Inquire into that. Yeah. I think it'd be awesome to discover it for sure. And if we could, I mean, if we knew how to do that, to measure it and manipulate it, then we would have anti-gravity devices, which gets into UFOs. I mean, they talk about these.
It doesn't exist, and it's nonsense.
Well, have you guys ever seen lights in the sky that track one direction? It looks like an airplane that's moving very quickly. All of a sudden it moves in another direction entirely. You could do that if you could manipulate the static field. You could move on a dime the way UFOs do. So the military may already have access to this. I suspect they do.
You couldn't, again, you cannot overcome inertia just because you're using electrostatic forces. It's just more nonsense, Geo.
You can create a field.
You can, if you get enough power, but you got to get more power.
Oh, Lemon, you cannot overcome inertia with any amount of power.
You need a flux capacitor. Flux capacitor, man, it gets you there.
You really want to live in Hollywood.
You need more power.
Fair enough, but don't come on here trying to tell us that this is what our reality is.
Power.
I'm actually, just to be clear, I'm not saying it's what your reality is. I'm saying it's what my reality is.
It's the type of power that you get with standing waves and frequency and resonance.
I'm clearly stating it's my viewpoint, and I respect whatever yours is.
No, you stated that you know that this is what it is.
That's correct, but I'm not telling you to believe it. I'm not telling you to know it. I'm just telling you what I know. Yes.
Doesn't stand up to the simplest inquisition.
It's fair enough. Geo knows this in his own head. I mean, that's as far as it can go.
Yeah, look, he's being polite, guys. It's like there's no need to go in.
Yeah,
I
mean, that's the limitation. That's where he's at.
I opened with accepting the fact that he very accurately explained how he's wrong. I mean, I get that. Yes.
Okay.
It's That's correct. The
So
thing
can we
is, you just
explore
need
this?
more power to get the anti-gravity effects that you're talking about. You need more electricity, more frequency, more resonance. We're getting there, though.
Even a magnet can move around a magnetic field and can essentially hover, things like that. If you could create a device that could essentially warp the ether, you could make those kinds of movements. And if that field enveloped you within its own field, you might be able to make hairpin turns like that, and all of the physical matter in your body would go with it.
And now we're on to the ether.
Yes.
Which doesn't exist. Been proven to not exist.
They call it space-time, quantum foam, quantum fluid. They just
don't call it the ether.
call it a different name.
Lemon, they do not call it the ether. It is not the medium that is required for electromagnetic radiation to work.
You just say that the field just springs up wherever these virtual particles are? That it just forms its own field?
No, I'm saying that space-time as we know it, space has the property of being able to support either an electric or a magnetic field, and the combined electromagnetic field that is responsible for radiation of radio energy.
Yeah, different manifestations of the ether.
No,
I would agree.
You can have a magnetic field support. It's a property of space-time. There's no
just a
requirement
property that exists. It just happens.
I would agree with both of those things. I think you can use different words to come to different conclusions. I mean, the ether, if you're talking about the luminiferous ether, that's a particular thing, like in the late 1800s. The word ether actually precedes that. So when I use the word ether, I'm not necessarily talking about the luminiferous ether that they were talking about in the 1800s. I may have a slightly different usage of the word, which goes back a little bit more to the way the ancient cosmologies and the ancients used it.
The breath of the gods, that's what that's from. That was supposed to be the substance that the gods breathed.
Yeah,
that's why we call it
evacuated
air.
air.
That's why down here with us mere mortals, it's called air. A-E-R.
I love
the air is more evacuated up there.
The stars in the heavens being the gods that are breathing and shining into this earth. Into the world. I love that.
It's a story.
It's something that's real because the vacuum is purified ether. Just like as you get higher up, there's less air to breathe, the more purified
you're
ether.
the only human being that makes that claim.
Well, I agree with him. I think
connection to make.
You agree with him.
Lemon and I think
insubstantial or it has substance.
We're pretty much on the same page in a lot of ways with ether. I mean, this is and I'm not trying to say that it has to be this way for anyone in here, but our ancient ancestors always viewed the ether as, and I'm not even saying Lemon sees it this way either per se, but as an interface between the physical and the spiritual.
That doesn't work outside of a small portion of countries. You know that, right? The idea of the breath of the gods being a specific thing is limited to a small region in the Mediterranean. Try again.
A lot of different cultures saw it in different ways. If you're
Name
saying
one.
The term ether, I mean, in general, the ether is often referred to as the very high octave, the spiritual plane, and that ether
I'm hearing
to the physical, the world of the mortals.
Can we establish that one claim you just said, that there were other cultures? Do you mind elucidating at least one other?
Yeah, well, in a lot of the shamanic traditions, the ether is an essential component.
I'm sorry, which shamanic tradition, please?
Right, can you let each other finish? You guys gotta let each other finish, okay? Let's not interrupt.
Well, yes, because it's a generalized term.
Just let him finish. You're not listening anyway. You're just trying to embarrass him, but at least let the man finish.
Go ahead.
Okay, so the question is basically what other ancient cultures recognized concepts involving an ether?
Yes. That is your claim. I asked you to elucidate on one more.
I mean, I've been studying ancient cosmologies for over 20 years, so I mean, I don't know whether you want me just to randomly come up with. There's many. I was talking about some demonic
one, just one more, other than a Greco-Roman mythology.
Well, the Vedics had a very, very complex system of ethereal layers that go up from the earthly plane. So the earthly plane, and as you go in higher altitudes, they have very complex cosmologies of the different layers and different celestial objects that are at the different layers. And then they also have, and this is in the Vedics, the Vedas, which essentially is the roots of all Buddhism and Hinduism. And they call it Bhumandala, and Bhumandala is the Earth system. It's a level Earth, surrounded by a dome on top. And then the Bhumandala has the different layers of the ether, and they represent different spiritual octaves as well. So that's another one.
No, that's a loose association. They're not talking about the breath of the god.
May I say something? You have to have gravity.
If you haven't seen just some basic Vedic cosmologies, I'll post a couple. You can see the layers of the ether and how that intercepts with the earthly plane, the physical plane. Generally, all these ancient cosmologies, they have three layers. They have an upper world or an upper layer, which is like, the heavens, the spirits, whatever. You have the earthly layer, you have the earthly layer, the middle world, the physical earthly plane, and then you have the underworld. And those are all correlated with a wide spectrum of different, conceptions. But obviously the middle world would be the physical, earth that we're on.
So there is no all-enveloping ether. That's the basic tenet of ether, all-enveloping. And now you're talking about some other nonsense. So it doesn't apply.
The ether is all, I know I've been talking a lot, so I'll take a break. The ether is all of the matter from the earthly plane upwards. So the air, what we're breathing, atmosphere, all of that from the ground up is ether. But I'll take a break. I know I've been talking a lot.
I have one comment and one question for Bazaar. Bazaar, I know that there has to be gravity because we know there's gravity because you must have gravity, right? But also I wanted to ask if you knew that bacteria played rock, paper, scissors.
I don't care.
All right. It's good to hear you.
I'm posting another one that's kind of more of an artistic description.
That's all you just showed was someone's artistic representation of what was stated in the Vedas. Try again, dude.
So all you got is memes.
That's what we get with satellites, so you get something similar.
Just don't obfuscate the point.
Well, your question was, what other ancient cosmologies incorporated the concept of an ether within their cosmology? And I was describing this when the shamanic one is a different one, but the Vedics is one in particular as well. So, but in terms of that, what
the aether is clearly defined. I already gave you the description of what the aether is in the Greek. It's a Greco-Roman term. It's Latin.
Yes, and he ignored the 7 claims from the Greco-Roman Earth.
They were talking about the evacuated layer.
Just because somebody claimed the word ether has something to do with Greeks does not mean that that's the actual root of the word. And I'm talking about the word aether. So just because somebody said that doesn't mean that that's the root of that word or that concept.
Then where did the Greeks and Romans get it from? Just curious.
They inherited it from people before them, as most things they did. Like all their gods.
From who?
From the indigenous original peoples on the earth before them, before they came
in. I know what this is. Okay, you're a theosophist. Madame Blavatsky.
I'm aware
try again, dude.
That's not anything. I know about theosophy, but I'm not like a theosophist, if that's what you're saying. But I'm not
the ancient original people.
Yes.
I think there were many different kinds of ancient peoples. I mean, there's not just one. It depends on what area of the earth and what time and what layer of dimension, essentially, that you're in terms of that. But yeah, there's a lot of...
Yeah, that's Madame Blavatsky. That's the whole cosmic egg bullshit. Okay, now I've gotten a better idea of where you get your particular form of derp.
Well, that concept, the concept is very, very ancient. Whatever claim you've made about
it was invented in the 1800s.
Completely separate concept. But I understand your feeling like you need to say that. So if you need to say it, that's fine. But yeah, I'm not a follower of Blavatsky or anything like that. But yeah, I mean,
you don't have to be. I know that's the source material.
Been known about for a very long amount of time. This person is one individual. But yeah, I hear you.
Yeah.
Remember, guys, we don't have to tack on rudeness to everything we do. We can just disagree with each other in polite ways.
Yeah, I mean, sorry, my viewpoint in this discussion is not to convince anyone or be convinced. I mean, I'm interested to talk with others, to learn if possible, to hear other people's perspectives, but I'm not here to convince anyone. I'm not really here to be convinced either, because I really come to my own conclusions. I don't really look for others to convince me. If I want to find truth, I seek that out myself. Of course, I can still learn from others, and that's why I'm always all ears, because the more I can learn, the better. If there's an opportunity to learn, I keep my ears open. But meanwhile, just respecting everyone's viewpoint, and it's more fun that way for me.
Hey, Gio.
Oh, quick.
I'm very curious. Why did you ignore Aristotle and Ptolemy? Sorry, yes, Ptolemy. I'm Romanian, and I think I spoke it right. So because they have it in the ancient Greek and Rome, they have established a geography for the lands that have been conquered, and they have been sent their people to measure everything, just to have a clue where they are and what they're gonna do with the lands. So you have been taking everything what's around the religious parts, and you have ignored things that have been measured. Can you tell me why?
What are you referring to that's been measured? Did you say Aristotle and Ptolemaic? Did you say Ptolemy? Is that what you're saying?
Yes. In 100 or some, it have been Ptolemy, and Aristotle, it have been in 300 before Christ. Both that have been before Christ. And there have been established some claims, about the earth. And there have been passed through between the writings that we found that even today, because there have been going through even to the descriptions of degrees of angles, where the towns and the cities are situated. So how come you have ignored those things, and you have been going to, because you told recently, because you studied ancient things from 20 years, but you ignored those things, but you take it the other things. What was the reason, and what was the logic of that?
Well, I'm trying to follow what you're saying. If I missed something that was asked of me, my mistake, my apologies. I didn't know that I did. I think what you're talking about is the Ptolemaic model, in my understanding, it's a geocentric model, the Ptolemaic model. But I mean, we could talk about those claims of history, but I don't necessarily just buy into that. That's the exact history of things. But what measurements are you talking about exactly? Are you talking about curvature measurements during Ptolemaic's time? Or?
No. They have tried to establish in degrees where are situated things on the earth.
Right. Yeah, there's been a lot of ancient map making. So in terms of that, yeah, there's been a lot of maps that have been made, which I've seen a lot of the ancient ones, which depict essentially almost like an AE map, the azimuthal equidistance, similar to that, and also detailed ones involving the North Pole. Are those the ones you're referring to?
Yes, they have been from those maps. We still have the Arctic zone. We still have the equatorial. We didn't have the antipodes. I think. Sorry, maybe I have misspoken. And we have the Antarctic zone. So from those ancient maps, we still have those names. So I don't know what was in your mind to dismiss everything what we have been following from ancient times, and to go to something that is very, very bizarre, to go in ether and things that are most of them that have been described as the religious parts, not things that have been measured.
So what measurements are you you're talking about specific measurements during what time in particular? I mean, I think there's different things we're talking about. Like I was talking about potentially, like if we're talking about the Vedics, that comes way before that.
Greeks, they have been first people that have been tried to map the land that have been in their area, that have been the Phoenicians.
I would say, in my viewpoint, Greeks are very, very recent in terms of on the larger
I'm
scale.
talking about the Phoenicians. So after that, Greeks that have been, you're right, Greeks that have been took it a lot of things from the ancient people that have been before them. So from example, from Phoenicians that have been taking the alphabet and that have been changed it and that have been used it. And that have been took it from Phoenicians a lot of things, a lot of good things. For example, trying to establish where they are in the land that they are living and trying to do maps. So the Phoenicians that have been the first ones.
We pick and choose what we need. We took, from the Greeks there, good logic, and left there, catamite, prostitution, their man-boy love, mentor, tormenting, and other bad practices as well. So we don't have to take the whole, horse and cart, as it were. We take what we need to make the point of heliocentrism versus, geocentrism or whatever, ether, non-ether, or whatever in this case. We don't take the whole, package, as it were, especially when there's bad stuff.
Why you have been choosing to go to the religious part and not to go to the things that have been righted? And
the ether is a non-religious concept as well. It's the substance of space itself, with or without religion.
It is. It have been established long before everything else.
But you can talk about the ether outside of those terms and still be very intelligible. You don't necessarily need the breath of God to understand that space is some sort of substance, a repository of energy that's everywhere. So what you say doesn't necessarily follow.